Hey everyone, so who is a critical government agency to bring autonomous air taxis to fruition? We'll find out in 30 seconds, but first, click the link below to get your free AI resource. The resource is free and will help prepare you for an AI-dominated career. Also, please subscribe or like and share these videos. We need your help to spread the word on this channel. Also, support us on Patreon. Even $1 a month makes a big difference for us. And thanks so much for tuning in to the AI Guide, where we are making AI human by focusing on the human impact of AI. So, for autonomous air taxis to work, what must happen to make these a reality? 3 things. First, ground infrastructure to load and unload passengers has to exist. Second, get the aircraft certified by the FAA or the body in each individual country that certifies aircraft to carry passengers. And finally, fit these vehicles into the existing airspace design. NASA is driving airspace design in partnership with the FAA here in the US. And it's similar in other countries. When autonomous air taxis and cargo delivery vehicles fly above neighborhoods soon, safe operations will depend on their ability to detect and avoid other aircraft and obstacles, just like with self-driving cars. As part of NASA's broad portfolio of work on advanced air mobility, which is these autonomous taxis, researchers visited the Mountain View, California headquarters of industry partner Reliable Robotics. Check them out at reliablerobotics.com. And they went there in late February to observe flight testing. The NASA team collected data from multiple sources for analysis, including the FAA, primary surveillance radar data. So this is the main data that the FAA uses to manage air traffic. This data may be used in detect and avoid systems that would support future autonomous flight in the advanced air mobility system. So this means they are building the needed database to run the algorithms for autonomy. The test involved Reliable Robotics flying its Cessna 172 Skyhawk and 208 Caravan aircraft from the San Martin Airport in San Martin, California, in pre-selected flight paths between Marina and Stockton, California. The NASA team worked with FAA radar engineers, the Oklahoma State University Advanced Radar Research Center. Why OU? Because they're developing radar to better detect tornadoes earlier. For example, a tornado went right by the OU campus back in late March or early April. That's why OU has an advanced radar research center. They also worked with Reliable Robotics, NASA's Armstrong Flight Research Center in Edwards, California, and NASA's Ames Research Center in Silicon Valley, California, to collect all the data from the flight test. Data from at least 8 sources, including aircraft, radar, and weather, were integrated for analysis as a foundation for future research. So they're building the database for autonomy to do the research, to fit these aircraft into the existing airspace. Under current FAA operating rules, all pilots are required to physically see and avoid other aircraft from inside the cockpit. Autonomous or self-flying aircraft without human pilots will need onboard sensor capabilities such as radar, light, acoustic, or a combination of these sensor types to ensure flight safety. So when they say light, they mean LiDAR, and acoustic is sound, of course. The data and analysis from this testing will help researchers understand if primary radar can be used for detect and avoid systems to satisfy the rule's safety intent. So they're trying to figure out, in other words, is radar alone enough for air autonomy? Just to put that in perspective, Tesla, for example, see the next video, has been relying on optical or camera sensors only recently for autonomy with mixed results. And they had disabled radar, but will add it back in. In this case, they're trying to see if radar alone is enough for air autonomy. So NASA said, we appreciate the close collaboration with the FAA and Reliable Robotics to collect meaningful data from these flights to improve our collective understanding of using radar for detect and avoid. This was Brad Snelling, NASA AAM, or Advanced Air Mobility National Campaign Chief Engineer for Partner Activities. So this guy is one of the senior people at NASA working on advanced air mobility and autonomy. These landmark flights will help the entire AAM industry further understand about how future use of primary surveillance radar data can enhance aviation safety. So they're deciding if the FAA's primary radar data is enough to drive autonomy in the airspace. No clear certification or operating rules for detect and avoid systems have been established yet, and they have to be finalized for advanced air mobility. But if refined and validated, these tests can build a model that can be trusted and depended on by both industry and regulators to inform safe flight operations and build regulations. We believe high-quality primary surveillance radar data can save lives today, said Robert Rose, co-founder and CEO of Reliable Robotics. We are honored to partner with NASA on a campaign focused on making the airspace safer for everyone, and that includes piloted aircraft. They're going to roll this out for that application too. NASA seeks to combine this research with other data and complete the model and report to the FAA. The NASA research should be available to the public by the fall of this year, 2023. The analysis will complete a segment of advanced air mobility research by NASA's National Campaign Team, which focused on addressing several problems that must be solved for industry to operate safely and effectively. Other efforts included virtual tabletop exercises to plan for an automated airspace, and we did a video a month or so ago where a lot of that's already been completed. This finishes this year, this test, and then they need to test real-time communications with aircraft flights over Texas, and finally developing potential flight paths for an air taxi corridor using a simulator. Once these problems are solved, the FAA can then issue rules for autonomous flying. In the meantime, advanced air mobility will have live pilots ready to assume control, just like autonomous trucking and cars have started out. So it'll be consistent with the way autonomy has been developing with surface vehicles. So advanced air mobility with pilots will be here by 2025 because the first aircraft is in final certification, and full autonomy should arrive around or before 2030. Thanks so much for tuning in. Click the resource link below and please subscribe. We're getting very close to the magic 1,000 subscriber mark. Also, like and share these videos and support us on Patreon. See you next episode.